Turfgrass breeding at the University of Georgia. Turfgrass is one of the big industries in Georgia, and it contributes about $8 billion to the state's economy. Turfgrass is used in home lawns, athletic fields, golf courses and roadsides. Most of the turfgrasses grown in Georgia belong to warm-season turfgrass species. Today we will discuss how a new variety of turfgrass is developed. First of all, two superior parents are crossed to each other, which is fairly easy in warm-season turfgrass species as most of them are self-incompatible. Parents are grown adjacent to each other and seeds are harvested which will produce hybrid progeny. This is a crossing block of bermudagrass, where the diploid African bermudagrass is grown adjacent to the tetraploid common bermudagrass, and the resulting triploid progeny will be sterile. As every genotype has a potential to become a new variety which can be maintained by vegetative propagation, the progeny from each seed is multiplied in the greenhouse. From here onwards, the turfgrass breeding process can be divided into 4 phases. In the first phase, the greenhouse multiplied genotypes are planted in the field along with checks. As the goal is to evaluate as many genotypes as possible, only a single replication of each genotype is planted. These genotypes are allowed to grow for 2 to 3 years with minimal application of irrigation, fertilizers, pesticides and mowing. Due to this abandonment, only the hardy and disease-resistant genotypes sustain, and about 100 of these are carried to the phase 2. In phase 2 the selected genotypes are still evaluated at the single location but in replicated field plots that are managed more intensively, including regular irrigation, fertilization and mowing at appropriate heights. These genotypes are assessed on a regular basis for various performance factors such as establishment rate, color, density, resistance to diseases and insects, and overall turfgrass quality. About 10 to 15 best performing genotypes are selected at the end of phase 2. Phase 3 involves similar assessment to the phase 2 but at multiple research sites situated at collaborative universities or through the National Turfgrass Evaluation Program. This helps to assess the genotype and environmental interaction, which plays an important role in turfgrass performance. Phase 4 consists of advanced yield trials, which are designed according to the specific breeding goals. For example, genotypes being developed for the golf putting greens are subjected to intensive low mowing. The best genotype is released as a commercial variety and is licensed to a side producer for distribution. The University of Georgia's turfgrass breeding program is one of the best in the world. In 1946, Dr. Glenn Burton, also known as the father of warm-season turfgrass breeding, started a bermudagrass breeding program at Tifton, which was continued by Dr. Wayne Hanna. Currently the program is under Dr. Brian Schwartz and focuses on bermudagrass, centipede grass and zoysialgrass. Some of the best Bermuda grasses grown across the world have come out of this program. This program also houses world-class turfgrass research facilities and is involved in spreading the science of turfgrass to the researchers, university students and as well as to the general public. The turfgrass breeding program at Griffin was started in 1993 by Dr. Ronnie Duncan and is being continued by Dr. Paul Raymer, who focuses on the seashore paspalum, tall fescue and bent grass. This program has developed many improved varieties of highly salt-tolerant seashore paspalum which are being used on golf courses throughout the world. The Griffin campus is also home to Turfgrass Research and Education Center which conducts research on the various aspects of turfgrass, such as entomology, pathology, physiology and extension. This center also holds various turfgrass demonstrations for the students and industry. The Athens Turfgrass Research and Education Center, situated at the main campus of the University of Georgia, also houses many laboratories, greenhouses, and classrooms for conducting the research and for the training of future scientists. So, the University of Georgia's turfgrass program, supported by various research groups, will continue its efforts in developing improved turfgrasses, training future scientists, and will remain a world leader in turfgrass science and education. Thanks for watching.